In this video, we will learn how to use a table such as this combined with the given function in order to factor a polynomial and find all the zeros. First of all, this little part right here is just using the fundamental theorem of algebra. How many roots or zeros will this function have? There will be 4 because the degree is 4. Plain and simple. Now, remember that's counting irrational zeros that might have a, things like 1 plus radical 3 would count. Imaginary zeros like 3i and negative 3i, it counts all of those. Okay? And it even counts repeated zeros separately when we say 4. Anyway, so we're going to find those zeros. So, basically, the key is this. This is the same type of table you would get if you took this function and typed it into your TI-30 XS multiview. In fact, let's do that. Here's my TI-30 if I hit the table button. So we got x to the 4th power minus 9x to the 3rd power and there's the rest of it. So if I hit enter, and I like to start from negative 10. Okay, so I'm scrolling down, looking for zeros on the y side. So there's a 0 at 2. And notice 0, 2 is right here. And if I were to keep scrolling down, there's another one at 7. And oh look, there it is. So this table is the same thing as this table that we're finding on the calculator. So the point is, you shouldn't need a calculator for this. Alright, so let's use one of those zeros. So we have a 0 at 2. So let's use that in our synthetic division. So I will go 2 like this, and 1, negative 9, 23, negative 81, 126. Okay, so you may need a 4-function calculator at some point, but that's it. So if I bring this down, 1 times 2 is 2. Together this makes negative 7. Times 2 is negative 14. Alright, that's got to make 9. 2 times 9 is 18. Together these make negative 63. And 2 times negative 63 is negative 126. So that's 0. Alright, now I could do grouping right now. I'm noticing that negative 7 divided by 1 is negative 7. And negative 63 divided by 9 is negative 7. So I could do grouping right now. And this would make x to the 3rd power minus 7x squared plus 9x minus 63. The GCF is x squared. That's going to leave behind x minus 7. If I bring out the 9, that's going to make x minus 7. If I bring out the x minus 7, then I've got x minus 7 times x squared plus 9. If I set these equal to 0, let's see, if I go x minus 7 equals 0, that gives me x equals 7. Alright, that is this 0 right there. But if I set x squared plus 9 equal to 0, I'm subtracting 9 from both sides. That's x squared equals negative 9. Take the square root. Don't forget your plus or minus. X is equal to plus or minus 3i. So we're supposed to say what all the zeros were. Well, 2 of them are right on the chart, 2 and 7. So definitely make sure you write those down. So you would have 2 and 7, and then 3i and negative 3i. So we knew there would be 4, and there they are. Now, if you didn't feel like doing grouping, you didn't have to. Because we had 2 zeros to work with, you could just use the other 0. So our other 0 is 7, so I could put a 7 right here and keep going. So we're already finished with the problem. I'm just showing another way you could have done it. So if you didn't like grouping, you might have done this. So using the 7, 1 times 7 is 7, that makes 0. 0 times 7 is 0, that makes 9. 9 times 7 is 63. Now putting the variables back in, this is x squared, ignore the 0, and plus 9. So there, you've got your 2 and 7, and you include those. This can't be factored, so again you would set this equal to 0, and you'd get x squared equals -9, and x is equal to plus or minus 3i when you take the square root. Alright, either way you're going to get the same answer. Alright, so that was number 6. Let's take a look at number 7 real quick. The main thing about number 7 is that we can think about the fundamental theorem of algebra again. So students were asked to find all the roots of this function. Patricia claims that the only roots are -1 and 2. Is she correct? Well, one thing is that the degree is 4, so we're expecting to have 4 roots, not just -1 and number 2. So if you wrote that down, I'm going to give you credit. Alright, so that might look something like this, and I would give you credit. However, you really should be careful because it is possible that these are double roots. In other words, imagine that you had a polynomial that factored like this. What if we had x plus 1 squared and x minus 2 squared? Well, such a polynomial would only have 2 roots, -1 and +2. Alright, even though the degree is 4, it's just that each of these is a double. And, you know, if we were to graph it, it would bounce twice. So, it's not necessarily true that Patricia is wrong. So if you really want to be sure, you need to go ahead and find, you need to do synthetic division and see. Alright, so I'm setting up synthetic division. I'm using one of the roots that Patricia said she found. So 1 times -1 is -1, that makes -2, times -1 is +2, that makes 9, times -1 is -9, that makes -18, times -1 is +18, which makes 0. So far so good. Alright, now we've still got this other root of 2. And normally I would just put the 2 right here like this, and I keep going, but I didn't leave myself enough space. So I just copied the coefficients over here, alright? Picking up from the 1, -2, 9, -18, then there you go. Alright, so we're doing this other 0, which is 2, okay, to break it down the rest of the way. So this is 1 times 2 is 2, that makes 0. 0 times 2 is 0, so that makes 9. 9 times 2 is 18, so that does make 0 again. So that leaves us with x squared plus 9, the third time I've seen this today. So if I were to set, this does not factor, so if I were to set this equal to 0, subtracting 9 from both sides gives me x squared is equal to -9. But then I would take the square root of both sides, not forgetting my plus or minus, and I would get x is equal to plus or minus 3i. So now I have guaranteed that there are other zeros because here they are. So technically this is what you would have to do to prove that Patricia was wrong. Otherwise it's possible that these really might have been the only zeros. They just could be double and double. Anyway, let's move on to number 8. So we're supposed to take this and factor it and find all the zeros. And we're not given a graph or anything, so let's just go ahead and use the calculator. Alright, so here I've typed it into my calculator, and I like to start at -10 because it rarely goes past that. Now I'm going to scroll down looking for 0 on the y side. Alright, there's 1 in there, but it must have been a decimal or fraction. Okay, so there's the first one I get, is at 2. Okay, so might as well write that down, by the way. So we have a 0 at 2, which means we have a factor of x minus 2. Alright, so let's go ahead and use that 0 of 2. So we've got 3, -7, 18, and 8. Three times 2 is 6. That's going to make -11. 2 times -11 is -22. That's going to make -4. -4 times 2 is -8, which does make 0. So now let's put the variables back in. So this will be 3x squared minus 11x minus 4. So if we factor this, 3x squared can only factor as 3x times x. 4 is either going to be 2 times 2, or if this doesn't work, I'll try 1 times 4. Inner plus outer equals middle. Inner, I have 2x. Outer, I have 6x. I'm trying to get 11. Most I can make out of this is 8. So this is not working. So it must be the 1 times 4 option. Okay, inner, I have 1x. Outer, I have 12x. I can get -11 if I go with -12 and +1. So here's my +1, and a -4 will go outer and make the -12. And +1 times -4 is -4. So this is the correct factorization. So 3x plus 1, x minus 4. Okay, this is going to give me a 0 of -1/3. And again, I'm getting that by setting 3x plus 1 equal to 0 and solving. So this will give me 3x is equal to -1, divide both sides by 3. That's how I'm getting -1/3. Alright, of course this is just going to give me 4. So this one should show up on the calculator. So let's look at 4 and make sure that there is a 0 there. And there you go. So, according to the fundamental theorem of algebra, since the degree is 3, there should be 3 zeros. So we've got them all. So that is the answer to number 8.